started. So welcome to developer-driven testing. Thanks everyone for coming. Developer-driven testing, increasing productivity and improving quality by removing the testing column. So before we get started, introduction for myself. My name is Lee. I'm a software developer. I have been developing software for about 15 years now. I work for Equal Experts as a consultant, and I've been doing developer-driven testing in some shape or form for about 7 or 8 years now, either doing it or helping teams adopt it. Okay, so first question, what is developer-driven testing? It's not something that I made up, but it's also not a very commonly used term. So I found that ChatGPT does know what it is, though, and gave me this really great definition. So developer-driven testing is an approach to software testing where developers take primary responsibility for testing their own code. I really like this definition because it uses the word primary, and it's not saying that developers are the only ones testing, but it does mean that they are the ones taking the lead and responsible for it. So a typical task board looks something like this. Hands up if this looks familiar to you. I mean, you may have slightly different columns, but the gist of it is that there's a testing column there. So in this workflow, developers will pick up items from the backlog, start working on them when they're in progress, and when they're done, they'll hand it over to testing. And I've often been in this situation where I've been working on something and, I see the first glimmer of hope that it's starting to work for the main use cases. And I think to myself, I'm sure there's still some problems here, but I'm not exactly sure where they are or what they are. I'm not entirely confident in this, but, I've come this far. And I know that there's going to be a testing phase next, so let me hand it over to those people on the team. And if they're happy, then I guess I'm happy, and I'm done with that piece of work. How familiar does that sound to people in the audience? That feeling? Okay, so what are the problems with this? So the main one, or some of the main ones are listed here. First one being handovers. So, what often happens working in this way is that the developer starts working on something. When they're done, they put it into testing. While that's going on, while the testing's happening, they'll pick up a new task, start working on that. But now the issues being found in the testing mean that you have to context switch back and forth between this item that you've just started working on and the item that you're trying to actually get delivered. And so, context switching and asynchronous communication often happens where you've got Slack messages between developers and quality engineers and comments on Jira tickets, and it just creates all kinds of problems and misunderstandings. The next problem is obviously bottlenecks. So when only certain people on the team are allowed to sign off on work, it creates a bottleneck. I've heard and seen situations where quality engineer might be not at work for some reason, and the team are blocked because now they can't deliver any work because it needs to be signed off for them to do so. Moving on to unclear responsibility. So,
ladies and gentlemen,
many developers write tests these days. Most do, I think, and we all do some testing on our work. But then quality engineers are considered responsible for ensuring that things are tested. So, who is actually responsible when there's an issue in production? Was it the developer who maybe caused the problem and didn't notice it themselves? Or was it that the quality engineers who were testing the work didn't find it as they were supposed to? So it's really unclear who's actually responsible in this situation. And then the last point is around feedback. So as a developer, you get slow feedback, which, as we all know, problems are much more expensive and slower to fix when we find them later on in the process. And all these problems, they can often cause the working relationship between developers and quality engineers to become strained. And I think many of you might be familiar with that situation. I've worked with some great quality engineers, and we've never had too many problems, but you can sometimes feel a bit of tension there, mainly due to the unclear responsibility. So what does good look like? So same board as before, but as you can see, we've removed the testing column completely. And the idea is that developers take work from the backlog, move it into in progress, work on it there, pulling in support from the rest of the team, testing themselves, maybe doing some pairing or code review, and perhaps pulling in some support from a quality engineer on the team. But at the end of the day, the board is it's either in progress, and once it's ready to be deployed, or once it's deployed, it moves into done. And that solves a lot of the problems that we just spoke about. So handovers. So there are no longer any handovers. The developer who the task is assigned to takes the lead. And doesn't hand it over to anyone. They see it through all the way to production. There are no more bottlenecks because now we don't have that. Only a certain few people on the team can sign off on work before it can be released. And responsibility is a lot clearer. So everyone takes a turn being responsible for their own work. And so it's a bit like if you've ever been on call, everyone in the team shares that responsibility, but at any one time, it's very clear who is responsible for, dealing with issues in production. And then lastly, this all just increases or decreases the time to get feedback. And developers are a lot more incentivized to verify their work as they're doing it, because doing it after, is just going to be very slow and not give you that quick feedback. And while all of this is going on, we'll get into this in a bit more detail, but quality engineers don't test for developers, they test with them. And what are the benefits of doing it this way? So these are in no particular order, but developers are empowered. So there's that quote about great responsibility, with great power comes great responsibility. And developers are empowered in this workflow to release when they feel confident. They don't need sign-off from anyone, and just creates that feeling of ownership and pride in the work that we do. The second one is about unlocking the value that quality engineers provide. So if your quality engineers are constantly testing work for developers, they're going to be so busy doing that you're not going to get any other value from them. You're not going to be able to unlock all that value that they can provide in many other ways, which we'll also get into a little bit later in a bit more detail. The third one is just around that team dynamic that we spoke about earlier. So working in this way, I found has a very positive effect on the working relationship between developers and quality engineers. Improving quality also happens because you've now got quality being considered much earlier in the process rather than something that's added at the end. And increasing productivity, well, that comes from not having bottlenecks and handovers and slow feedback. So next, I'm going to just talk a little bit about implementing developer-driven testing. Just talk through a couple of points here. So pairing or code review is strongly advised because you don't want developers just going rogue and just doing whatever they like and going straight to production without any other people in the team having eyes on the work. The pairing can be with quality engineers or other developers on the team. You'll know in your team what is the best way to go about that. And as we mentioned, quality engineers are testing with developers, not for them. So immediately you can start this process in a team just by saying, okay, when something is in the test column and it's ready to be tested, your quality engineer can pull the developer in and sit with them and actually test with them and go through what they would normally do to verify a change. And as long as you do that together, you can start to do developer-driven testing or start to implement it. Okay, changing the column name or removing the column. So as long as you have that column in place, you're always going to be reinforcing that idea that it's another step in the process, and associate that with your quality engineers on the team. So on teams that I've worked with to introduce developer-driven testing, what we've done is change the column name straight away for teams that aren't comfortable removing it, and we've done something like call it ready for showcase or something like that. And really when that's just used for a team to sort of show, a developer to show the work that they've done to the rest of the team and demonstrate, okay, this is how I've verified this, and these are the tests that we've done. Give people a chance just to have some comfort that something is not just going to production that no one's seen before. But I do recommend eventually, removing that column completely. So the next section is about, the next point on the slide is that developers intentionally focus on their testing skills. Testing is difficult, as we all know. So the next part of the talk, I'm going to just talk about some of the things that we can do to improve how we write tests and how we think about tests, so that we make our tests a lot more effective. Because when there's no safety net, developers need to improve their testing skills, their automated testing skills, and they need to go beyond just testing theater. And testing theater, to explain what that means, is really just testing as a box-ticking exercise. And I think a lot of people will be familiar with those kinds of tests that aren't actually giving you confidence or aren't really providing value, aren't verifying anything, but they're sort of done because testing is something that you're supposed to do, or it's sort of a expected thing to do. So really what we want to do is move past that and really make our test effective. And these next couple of slides are going to be about some of the tips and important points that I've learned over the years in really making your test work for you and give you confidence. So I might be preaching to the converted with some of these. I know a lot of you are probably familiar with some of these practices and ideas, but I'm going to just go through them anyway. This is an important one. So test behavior, not implementation. So a lot of tutorials out there when you're getting started with things like test-driven development, they show very simple examples where you take a class and then you mock out all the dependencies of that class and you test the function and you do it at a very, very granular level, testing each method of each class in isolation. And unfortunately, this is a very common problem that I often see, and unfortunately, this really just doesn't work, because when you've got tests that are testing the implementation, it's really hard to do things like refactor, to make you make a small change and all your tests break, and you're not actually able to make changes and improve the structure of your code and the design of your code, and the tests are really just getting in your way and not providing a lot of value. So testing behavior often means testing at a much less granular level. So I'm going to just show a quick code example here. So say, for example, we've got a shopping cart, that you can add products to, and it's got a method to calculate the total, that total price of all the items in the cart. You might decide that, well, it's a good design to have a calculator class that does the calculation for me and not have that as part of the shopping class. And you might think, we'll model it that way, which is a really good idea, I think. And this is obviously a simple example, so please forgive any problems with the code. I know things like thread safety, and there's a bunch of smart developers in the room. I'm sure you can think of many ways to improve it, but you get the idea. So when you think about testing the implementation and all the tutorials online that promote that idea, they would say, okay, the shopping cart needs to take a shopping cart calculator as a dependency so that I can just focus on testing the cart. And this is what what that would look like. And it would lead you to write a test that looks something like this, where you create a mock calculator and you pass that into an instance of your shopping cart, and you verify that mock was called, and then you check, okay, do I get the total back that I expected for the items in the cart? And as you can see, the problems with this, as we just described, you can't refactor this without. You can't say, oh, well, I don't want to have a calculator anymore. I want to maybe bring that into the main class itself, or I want to have a whole different design where I've got a strategy pattern with different calculators and things like that. You can see that when you've got a test like this, you're going to need to change this test. And it's not going to allow you to do that very easily, to change the design. So a better way would just be to focus on the behavior of the cart, because that's what we care about. We don't care that it's implemented with a calculator or anything like that. We just care that the cart, you can add items to it, and you can get the total, and you get the value that you expect. So the next point is around tests that are supposed to fail. So we write tests for a reason. They are supposed to fail when the code doesn't behave the way that it should. So a recommendation here is to use strict assertions. When you use relaxed assertions, you can, your tests aren't too strict about the output. You can have problems in your code that your tests aren't picking up. And that's really what we want from our tests. We want them to fail. Another point on this is just to remember to make sure that you see your test fail. So if you are in the unfortunate position of having to write the test after the code, make sure you go and play around with it and break that code and make sure that when I break it in this way, my test is picking up that, that's not behaving correctly. So just some examples on strict assertions. So let's say, for example, we have a React component that renders a message. We might write a test like this that, gets that element by the text and then says, oh, I want this message to be in the document. If you look a bit more closely at this, though, you can see that query by text only, will fetch an element if the text is contained within even a much larger bit of text. So you could have 1 million lines of unwanted text on your page. This test will still pass and not pick that up. And it also only checks that it's in the document. That's not something that our users really care about. They don't care that there's something in the HTML document on a page. We could write this in a much better way. First of all, by being explicit about the text that we expect. Get by text does an exact match, and I've also added a regular expression to say that I want it to be case sensitive as well. So now we're being really strict about what we expect, and a slightly better assertion over to be in the document is something like to be visible, because I really like the way that reads as well, because that also keeps us in that mindset of thinking about what is the behavior that our users care about, and that is they want to see this text on the screen. Another example on assertions. let's say you got a component that, makes a fetch request. I often see people writing really simple assertions. They just say, okay, expect that this fetch mock was called. But you need to be a lot stricter than that. When you verify that something was called, verify that it, made the right request to the right URL, that the request body was as you expected with all the right parameters, and make sure that it was called the number of times that you expect as well. Sometimes you could have a problem where there's a loop in your code, and it's firing thousands of requests. Your tests are not going to catch that if you don't do something like this and be explicit about how many times you want that to happen. Making your tests realistic. I was having an interesting chat earlier with someone about this, and the idea is that you want to really test your code in a way that's as close to the way that it runs in production as possible. So a couple of years ago, I was working on a project, and we had a dependency injection class that set up all the dependencies for our application. And then we had a separate one that we used for tests because we wanted to inject some different stuff in there. And these two were never kept in sync. Yes, we did want to mock out a couple of those dependencies, just the key ones that made database calls or things like that. But what we ended up with was an application that we were testing that was configured in a completely different way to the way that it actually ran in production. And you can see that by doing that, you're just not going to catch a whole lot of problems that you could otherwise. So this last point is around assuming that your code has issues. As developers, we often look for the first sign that things are working well, and we're really happy when we see, okay, this is this is starting to work now. I'm actually getting somewhere. We come at things with it's often quite an optimistic mindset, but we do need to adjust that if we're going to be the ones doing the final testing of this code. We need to be a lot more critical, less optimistic, and we need to be in that mindset, early on in the process and as we're writing code. And your quality engineers are really good at this. So go and speak to them, pair with them, and they can really help you adopt this mindset and use it to your advantage. Yeah, just to recap my top tips for writing effective tests: test behavior, not implementation details. Your tests are supposed to fail. Make your tests realistic, and assume that your code has issues. And when you've done all the tests and actually you can't find those issues, then you're in a good place. So the next question that comes up is, what do quality engineers do if not testing? Now, I'm not going to give an exhaustive list here. There's a lot of things that quality engineers do that provide a lot of value. They have a lot of skills that are often underutilized. And so there is a lot more that they can be doing. Things like promoting a quality mindset within the team. We just spoke about that on the previous slide, helping people to think critically about the product. Holistic testing. So this one came up recently in a discussion I was having with a team that's recently started working in this way. And when you're working on a certain area and you're delivering a lot of features in a certain area of your product, you are getting a lot of test coverage in that area because you're testing as those features are being delivered. But if you happen to move on to a totally different area of your product and work on that for a couple of months, any problems that were there that you missed or since come about in that original area, your quality engineers are going to be so busy looking at the new features, trying to keep up with what's happening there. You've often only got a couple of quality engineers and way more developers on a team. They're not going to have time to look at the product and test it in a holistic way. And so, in a discussion with this team that I was working with recently, this was one of the big things that the quality engineers were really happy about. They were saying, look, I have found so many problems in so many bugs that have been there for such a long time, and actually they've probably been annoying our customers. And now we've had the opportunity to go and find those and fix those, and we're feeling a lot better about the product as a whole. Other things that quality engineers can do, obviously contribute to automated test suites, even write production code. On teams I've worked with, always been happy to receive contributions for production code as well as tests from quality engineers. They're often very good at finding those gaps in our test suites and identifying, another edge case that isn't quite covered. They can fill those gaps. Pairing is another great one. I think we already touched on this one. Code review as well, to also sort of make sure that the right level of testing is there. And identifying risks and areas for improvement. So, perhaps things like accessibility. Maybe on your website or application, accessibility isn't very good. Quality engineers can go away and look at different tools for, making testing accessibility and making improvements in those areas, triaging the results of those tests and feeding that back to the team. So there's a lot of value that QEs can provide when they're freed up from having to test everything. So, in summary, developer-driven testing is about adopting a test-oriented mindset and enabling your quality engineers to provide more value. The columns, the process they represent, they shape our perception of where responsibilities lie. They're very powerful in that way. There's a lot of talk in the industry about shifting left and moving quality to the left. And I found that developer-driven testing is a really great way to make quality a part of the process and to actually start achieving that. So, thank you all for listening. I hope you're all having a fantastic event. Thank you all for listening. Happy to take any questions now or at the stand afterwards. Come and see me. My details are on here. You can email me, find me on LinkedIn. Does anyone have any questions now?
Advocating for dropping the testing column from your storyboard entirely. Yep. That's quite bold. So do you also advocate for dropping your environment, like your SIT environment or your UAT environment altogether? Or what happens in your SIT environment if there's no more testing column in your storyboard? What does a practical deployment then look like after the PR has been reviewed and merged? Is that the end of the story, and from there it goes into production?
So it's going to be different based on different contexts, but I think if I can try and answer the question in a general way, the process with the pipeline and path to production is still there. We're not talking about not doing half of it or skipping some tests or not advocating for that at all. Really, when you don't have the testing column, it's really just about making sure that you don't have a handover to another person who's going to verify things, separately, not with the developer. Because really what we're trying to promote is that ownership and responsibility. So I think, as I mentioned on one of the slides, developers deploying all the way through to production is highly recommended, because I've worked with teams where they say, okay, the QA is going to test something, and when they're happy with it, they will deploy it. And I really think that does a lot to also diminish the responsibility from the developer's part. They just okay, my job is to to get it to a state where it's like a release candidate where, okay, this thing could work, let me send it on. And I found that you get much better results if a developer deploys it through to production. They understand how it gets deployed. They can monitor the feature after deployment and see, okay, yes, I'll go onto the site, I'll see, yes, it is there. It is actually, feature's been deployed successfully. Check the logs, yes, it's being used. We don't have any problems. So I feel like that deployment process, although not strictly related to removing the testing column, it's really a part of the same idea. Hi.
I have an interesting question that I'm trying to frame properly. I was in a very small team, which now is like one. And my senior was like, we don't need tests. And so I eventually, when he left and I took on his role, I started doing integration tests. We don't have unit tests basically.
Okay.
Built-in ones in the framework.
Yeah.
But point being, I'm looking at trying to grow our team, I hope. And how do you convince other developers? Do you bring on a developer and get them to run it, to build tests properly, or do you bring on like someone junior as a tester and then get them to build up their experience in development? And like, I guess the question is, do you force developers to test? Or do you teach testers to develop?
Yeah, that's a great question. I think I should have maybe been a bit clearer about that in the talk, because motivating developers to test is can be difficult, and that's why something like developer-driven testing has it's a big motivation for them to do that, because now they're not only concerned with writing the code. It's part of their role to actually test it as well, because they're ultimately responsible for that piece of work being successfully delivered to users and providing value there. So yeah, I feel like it does have that effect of encouraging the right behavior. And I think that's, when I say the right behavior, I mean encouraging testing.
I wanted to check, so with this model that you were talking about, is the ultimate goal to have a dev team that should see the code through from the requirements to production without other people, and ultimately dissolving, calling that the role of the feature analyst is the majority of the team?
Yeah, so that is a great question. This question often comes up when you propose deleting the testing column. Your quality engineers whose job it is to do the testing in that phase of the process, they often think, "Oh, am I being, made redundant in some way?" And there's another ex-colleague of mine who's been doing this for a long time. He's a quality engineer, and he uses the term, have I just talked myself out of a job? And then he says, no, I've actually talked myself into a better job, because as I described in the talk, there are so many other things that you can do when you're freed up from just checking that what was supposed to have been done has actually been done. The basic acceptance criteria on a piece of work. If you can free yourself up from doing that, there's actually a lot more that you can do, and it's a lot more enjoyable to be a quality engineer in that kind of a team. You provide a lot more value, and just more enjoyable. Any other questions? Actually, we're out of time. If you have questions, please come and find me. Thank you, everyone.